last week lecture, okay, the last subtopic that we have discussed was the calorimetry. Okay, right. So for calorimetry, we use a device to measure the heat absorbed ataupun the heat release from the reaction ataupun by the reaction. Okay, so we have two types of calorimeters. So we have constant volume calorimeters, or also known as bomb calorimeter, and also constant pressure calorimeter, or known as coffee cup calorimeter. Okay, all right. So for constant volume calorimeter or bomb in specific, uh, of course, we will be calculating the heat release. Okay, so we will be calculating the heat release, and please take note that if the question is asking for energy change, okay, for bomb calorimeter, the question can ask for the energy change. So the energy change is equal to the heat release over the mole. Okay, over the mole for the substance given. That would be the E lah. Okay, if the question describes ataupun conduct mention that the coffee cup calorimeter is used. Okay, so you should know that, of course, okay, we will be calculating for the Q. So for Q, it can be endothermic, it can also be exothermic. Okay, but for bomb calorimeter, it can only be exothermic reaction because the device is designed for an exothermic reaction. But for coffee cup calorimeter, okay, it can be both. It can be endothermic and it can also be exothermic. Okay, all right. So one thing that I would like to highlight is that the Q is equal to the enthalpy change. Okay, if the question highlighting on the enthalpy change, which is delta H, okay, so you should know that it is also equal to Q divided by mole of the substance given. So basically, is the formula is the same. It's just that the representation used. Okay, so you still need to divide by mole. It's just that if we are using coffee calorimeter, it should be the energy change, not the delta H. Same goes to if we are using coffee cup calorimeter, okay, it's still the delta H is still Q per mole. It's just that the representation is not delta E, it's delta H. Okay, all right. So for bomb calorimeter and coffee cup calorimeter, okay, so the most important thing is to describe the system and the surrounding. Okay, so we have the Q system and Q surrounding. Same goes to coffee cup calorimeter. Okay, so the Q reaction would be is equal to QH2O plus Q calorimeter. Again, this is depend on whatever information is given in the question. Okay, all right. Sometimes the mass of H2O is not given, but we only have the calorimeter information. Okay, so that in that case we don't have to consider for this one. Sometimes the mass ataupun the information for H2O is already embedded ataupun inclusive in the calorimeter. Okay, all right. Same goes to coffee cup calorimeter. You are going to be using the same relationship here. Okay, it's the same. Okay, all right. It's just that sometimes this one H2O, it can be H2O, sometimes it can also be solution. Okay, all right. So it's just that it depends on the information given to you. Okay, if the calorimeter, the C calorimeter is not given to you, that means we can assume that the Q calorimeter will be 0. Okay, so if the C calorimeter is given to you, that means you have to consider for the Q of calorimeter. Okay, so it shall not be 0 lah in that case. Okay, so dia kata kat sini coffee cup calorimeter has negligible heat capacity. right? Okay, so to calculate the solution ataupun H2O, we're going to be using MCS delta T. For calorimeter, we are going to be using the C, capital C, okay, calorimeter times delta T, right? Okay, so we have discussed the examples, okay, uh, on how to solve this problem related to calorimeter. Okay, all right. So we have checkpoint. Okay, all right. I suppose that everyone have completed the checkpoint. So saya dah pesan macam biasa. Okay, kalau kita habis tu ada checkpoint, even though I did not apa nama tu, saya tak ingatkan kan. Faham-faham sendirilah. Okay, so that is your responsibility. Okay, so we have checkpoint 10. Okay, so let's discuss checkpoint 10. Please check your answer. Okay, so this is the substance that need to be burned, undergoes combustion. Okay, so this sucrose will be burned in the calorimeter. All right, we need to know what type of calorimeter is used. Okay, so the temperature rise, of course, it will rise because this is a combustion reaction and it is an exothermic reaction. And it is proven by the increase in temperature of the, in this case, okay, they transfer the heat to the water ataupun calorimeter. Okay, that is why the temperature increases. Okay, exothermic, release the heat. Calculate the energy change of combustion. Okay, highlight the energy change. That means this is the delta E. Okay, of combustion of sucrose, the heat capacity of bomb character. No wonder, again, the question is asking for bomb calorimeter. And no wonder the question is asking for delta E, because the bomb calorimeter is used instead of coffee cup calorimeter. Okay, so this is the heat capacity, and this is the molar mass of the substance, the sucrose. Okay, all right. So there's no information given for the water. Okay, tak ada bagi information pasal water ke apa. Alright, so first step, you have to look for the Q. You have to look for the Q first. Okay, so it should be Q reaction is equal to Q calorimeter. So since we know that this reaction is an exothermic reaction, okay, so we have the negative to represent the exothermic reaction. Okay, all right. So since we only have calorimeter, we don't have the water. Katakanlah, okay, all right. Okay, we don't have this information. That means kita delete je lah, buat pangkah macam tu. Right, so Q reaction is equal to Q cal, and Q reaction is equal to C delta T. Okay, all right. So you insert all the information. Okay, you shall get a negative value to represent the exothermic reaction. Okay, all right. So this is only for the Q, guys. This is only for the Q. Okay, don't forget that you have to find out the delta E. So the delta E is equal to Q over the mole of the substance. And by right, you should get kg per mole, because you divide the value with mole. Okay, all right. So you patut dapat kg per mole lah. And then after all, the heat capacity is given in kJ degree Celsius. kJ, it's already in kJ. Okay, all right. So this is the answer. Okay, you should get this negative value of the Q. Okay, all right. So this one is the value, and then when you transfer to the other side, you should get negative value. And it is exothermic that it is proven that you got negative value, okay, to confirm that the reaction is exothermic. Okay, all right. So don't forget this, guys. Normally student, common mistake student, dia stop kat sini. Cari Q je. Okay, all right. Don't forget. That's why saya kata you have to highlight this. Bulat, buat bulat. Lagi besar. Nanti kau mesti, kenapa bulat besar melampau ni? Okay, right. This is just to remind you, okay, so that you need to extend your calculation. Okay, all right. Checkpoint 11. A sample of carbon weighing 1.07 gram is completely burned. This is again a combustion reaction. Okay, in an excess oxygen in a bomb calorimeter having a heat capacity of this. Okay, the temperature of the water, this mass of water in the calorimeter rises from 20 degrees Celsius to 24.8 degrees Celsius. Again, calculate the energy change of the combustion. Okay, the energy change. Okay, but this time around, the mass of water is given. Okay, all right. So you're gonna have this first. This is an exothermic reaction, right? So Q reaction is the system is reaction lah. Okay, so kita straightforward terus reaction. So Q reaction is equal to QH2O. Okay, so these two are the surrounding. These two are the surrounding. So when the moment the heat is released, the H2O will be accepting the heat and also the calorimeter. Okay, after we have the water, we have the calorimeter. Okay, so these two are the closest one. Of course, the first contact would be the H2O lah. Okay, all right. So you're gonna insert the information, okay, for H2O and calorimeter. So the mass is already given. So the H2O CS delta T, okay, this is for water, this is for calorimeter. So the mass is already given, okay, the mass is already given. Please check, okay, to be safe, just check the unit used for the heat capacity of the calorimeter. Is it gram or is it kg? Okay, if it's kg, that means you have to change this one into kg. Okay, if it's G, then it's okay lah. If this is G, then given is the kg, you have to convert into G. Okay, please make sure of that. So that is why unit is very important. Okay, sebab dia boleh play around with the unit. If the unit here is G, then here the unit is given in kilogram. You tak biasa buat unit, you pakai the information directly. So there you go. Okay, you will lose some mark there. Okay, alright. So masukkan je lah, and don't forget you akan dapat the Q reaction is equal to negative value. Right? Don't forget the delta E is equal to Q. So it should be negative value. Okay, don't forget the negative, guys. Carry the negative. That is also another common mistake. Okay, divided by the mole substance. So again, you should get kJ per mole. Okay, all right. So this is how you should prepare your answer. Okay, all right. So this is for QH2O. This is for QCal, and then you insert both. Sorry. Okay, you insert both into the formula. Okay, so this is the one, and then this is the final answer. Okay, don't forget to include the negative sign. If not, buat penat je, because this one will be 1 mark, guys. Okay, if you miss this one, that means you miss out this one. So your 1 mark will be gone lah. Okay, right. Okay, another example. Oh, this one is using the limiting reactant, right? Last time. Okay. Regardless, whatever it is, first step before you determine the mole, this is just to find the mole that need to be divided at the final stage. Tapi yang dekat atas tu, you still gonna be using the QMC delta T and QCal. Okay, tak pakai pun mole-mole bagai tu. Mole tu later, last kali, the last stage, you have to check. Okay, in this case, you ada 2 mole kan, you ada 2 possibility. Bila 2 possibility, which mole that need to be used? Remember limiting reactant. Okay, ada that possibility. Okay, alright, especially for coffee cup calorimeter. Okay, right, so we have checkpoint 12. Okay, how about bomb calorimeter? Are you guys doing okay there? Okay ke so far?
Okay, madam.
Okay, madam.
Okay, so far so good, alright. Okay, checkpoint 12. A 50 ml of 0.1 molar silver nitrate is reacted with 50 ml of 0.1 molar HCl in a coffee cup calorimeter. Okay, all right. So as you can this is just to alert you guys, okay, to make sure that you are aware of the situation that we have now. Okay, we have two information is given there. Cukup ni, maksudnya we can extract out the mole. This is for silver nitrate. This is for hydrochloric acid. Okay, ini just nak alert kan. Tapi tak semua, mungkin there is a possibility of limiting reactant. But mungkin tidak. Okay, so what should we do? We have to check. Kita kena check. Tak semesti dia apa nama tu limiting react, dia ada limiting reactant. So how do we know that? We have to check. Okay, alright. So the temperature change from this to this. Okay, so it is increasing. Betul tak? The temperature is increasing. Therefore, dia dah idea. Bila dia increase, okay, that means the heat has been released. That's why when we measure the temperature of the surrounding, okay, we can determine the type of reaction that we are having. Okay, alright. So the increase. So kenapa? Macam mana boleh increase? Maksudnya the surrounding is absorbing the heat from the system. So the system is exothermic. The surrounding is endothermic. Okay, alright. So this is the reaction. And the density is given. Okay, nampak density kena bagi. Bukan kena bagi, dia bagi. So agak-agak kenapa dia kena bagi? Remember bila you nak calculate the Q, you need the M, MCS delta T, right? Do we have M given in the question? No, it's not given. So that is why, okay, the density is given. The density is given to convert the volume to gram. Okay, alright. So you cannot just simply assume 1 gram is equal to 1 mil. Bukan. Melainkan dia dah bagi dekat sini. Oh, 1 gram per mil. So we can translate this. 1 mil is equal to 1 gram. Okay. Tapi dia kena bagilah. Dia bukan you pandai-pandai je assume mil into gram and then dah lah macam tu. Tak claim pula. Okay, you tak buat disclaimer dekat situ. 1 gram is equal the density ke apa, what not. Okay, you do not declare. So, tak boleh lah macam tu. Okay, in this case dia dah bagi. So, you may have apa nama a statement. Okay, for 1 gram, the mil, for 1 gram of solution, the volume is equal to 1 mil. Okay, and the specific heat of water is given. Okay, so this specific heat of water represent the solution. Okay, maybe it's too diluted. Therefore, the heat capacity of the solution is the same as the heat capacity of the water. Okay, alright, calculate the enthalpy change of this reaction. Enthalpy change, guys. So this is delta H. Delta H is equal to Q of reaction. Since this is an exothermic reaction, patutnya you punya value kena ada negative sign, okay? Divided by the mole of substance. So this is the formula. So now we have to find this one first. Cari Q reaction first. Okay, right. So Q reaction. So since we have determined that it is an exothermic reaction due to the increase in temperature just now, okay, so we could say that Q reaction, negative Q reaction is equal to Q solution plus Q cal. So these two are the surrounding. Okay, all right. So we have to check whether these information are given for solution, for solution and calorimeter. Okay, dia bagi, nampak ni. Solution, the mass, okay, we need the mass. Okay, bila kita expand, MS, yes, delta T, this is C delta T, right? Okay, so we need the mass. Okay, all right, so obviously it's not given, the mass is not given. But we can change, we can convert, okay, the 50 mil into gram by using the density given. Okay, all right, so this is 50 mil, 50 mil. This is for H, and this is for silver nitrate. Nitrate. Rajanya tulis pakai adalah chemical formula ya. AgNO3, okay. At 50 mil, okay, so for the density given, 1 mil is equal to 1 gram, okay, right, mil. So we have 50 gram of silver nitrate. And then we have HCl also, okay, 50 ml times 1 gram over 1 ml, okay, cancel. We have 50 gram of HCl solution. Okay, sebenarnya kita tak boleh simply 50 plus 50 tau, unless dia cakap assume that the total volume is the total of silver nitrate and HCl. Sebabnya ikutkan volume tambah volume is not equal to the total volume. Tapi gram tambah gram is equal to the total gram. Okay, ini topik 1. Pergi buka balik topik 1 punya tu. That's why saya buat secara asing dekat situ. Saya tak totalkan 50 plus 50, 100 and then convert into gram. Even though the final answer is the same. Sebab apa? Sebab kebetulan dia pakai 1 gram there. Okay, kebetulan dia pakai 1 gram. If this is not 1 gram, that means akan ada lari sikit lah value dia. Okay, alright. So, baru you total of solution 50 plus 50, okay, is equal to 100 gram. Then you can insert this into here. Okay, right. So, that's the plan lah, that's the plan. Okay, so and then you insert lah all the information into this formula and finally you calculate the Q. Okay, right. So this is the one. Okay, settlekan for this one dulu. Right. Okay, now nak bahagikan dengan mole kan, because delta H is equal to Q reaction over mole. Mole kat sini yang kita kena check. Okay, mole nak pakai mole siapa? Dia tak ada pun cakap, nampak tak? Dia tak ada specify ataupun dia tak ada bias to any of the reactants given. And this is not, what do we call that? This is not neutralization reaction, betul tak? Yang kita kita go for water, okay? Alright, dia tak cakap. Yes, we still have to check. Kita kena check whether ada tak limiting reactant tu. Okay, alright. So this is for silver nitrate. This is for HN. Oh, okay. Dia nak calculate from air lah. This is for HCl. Terkejut saya. Kenapa dia buat macam ni Dia nak cari mole of HNO3, which is the product, guys. Which is the product. Okay, dia nak cari the product. Dia pakai limiting reactant punya style. Okay, so okay, kita selalu pakai, ni dia punya tajuk dia, guys. This is the tajuk, okay. Dia tajuk, tak apa, no worry, okay. It's basically the same, exactly the same as the limiting reactant punya method that we have learned. Okay, this is cara dia, dia represent saya punya ni. Okay, kita kan selalu buat macam ni kan. Okay. Right, so dia nak determine the product chosen is HNO3. Okay, ni. Dia nak compare, ada tak limiting reactant ni. This one, okay. Alright, so bila dia check, this is using AgNO3, okay, it produce this amount of product, and if we are using HCl, it produce this amount of product. As you can see, the mole produce are the same. Bila dia produce a mole of product yang sama, maksudnya tidak ada limiting reactant di sini. There's no limiting reactant because both of them will be completely used up at the end of the reaction. Nampak tak? Limiting reactant, case limiting reactant ni, bila limiting reactant akan habis dulu, then we have an excess reactant there. Okay, so that is limiting reactant. But another type of reaction adalah di mana all the reactant have been fully used up, completely used up. Dua-dua habis serentak. Okay, and they produce the same amount of product. So in this case, we don't have limiting reactant. Tapi kita still kena check. Dia ada ke tak ada? In this case, dia tak ada limiting reactant. Okay, so in this case, kita pakailah. This will be the mole. Alright, okay, so this is the final answer.
Madam.
Yep.
Yang ni apply untuk dua solution je ke ataupun more than that?
more than that pun boleh, more than 2 solution pun boleh. Cuma kita nak bagi awak banyak, normally it will only involve 2 reaction. Okay, two solution lah. Okay, 2 reactants. Sebab apa? If we give you more, you are still going to be using the same method macam ni. 1, 2, okay. Kenapa nak bagi banyak-banyak? Okay, kita nak test you pandai tak? You have to check for each one of them. Kalau kita bagi 3 ke 4, you are still going to be using the same method. Kan? Maksudnya kita test you benda yang sama and it takes time for you to produce the final answer kan. So normally kita go for 2. Kadang-kadang kita nak extra, kita 3. Tapi we don't go more than that lah. Okay, but normally it will be 3. 3 pula, 2. Okay?
Madam, satu lagi, kalau soalan tu dia tak mention pasal specific heat capacity untuk calorimeter tu, meaning dia boleh neglected kan?
Heat capacity for the heat capacity is not given, maksudnya kita assume that it is 0 lah. Okay? Right, kita boleh assume that it is 0. That is very important. Jangan, nanti kan pening, mana nak cari heat capacity? Kan saya kata tadi, depends on whatever information is given to you. Okay, kita tak boleh nak main pukul rata, okay, aku mesti kena guna this formula. Kena ada this QCal. Ataupun kena ada this Q solution. Not necessarily. Okay, so kalau dia tak given, macam mana kita nak korek the information of the solution? So that's why tak boleh, you kena describe the system. Okay, you imagine, okay, the reaction, release the heat supposedly kepada solution and calorimeter. And then when you go through the question, dia tak bagi information pada solution tu pun. Okay, dia tak bagi information pada solution. Then how do we calculate? How can we calculate? Okay, tak apalah, tak payah pening-pening lah. Gunalah, maksudnya dia still bagi the information on the calorimeter. Okay, sometimes dia tak bagi QCal at all. Dia tak bagi information on the calorimeter, dia bagi information pasal mass of the solution and whatnot. Then the solution lah, sebab dia adalah the system release, the surrounding will be absorbed. Okay, so cerita dia macam tu je. So you define lah apa yang surrounding yang ada. Kan macam saya cakap kan, so macam saya ni kan, okay, saya adalah sistem saya adalah sistem. Saya define saya adalah sistem. Okay, so the rest are all surrounding. So pad ni surrounding, yang direct contact dengan baju saya surrounding. Okay, yang direct contact dengan saya. Yang jauh-jauh maksudnya yang bukan direct contact dengan saya, pintu kat sana tu, so that is not direct contact with me, but it is still my surrounding. Okay, maksudnya bila nak kira heat release by saya, dia antara yang mungkin the amount absorbed, the heat absorbed by the pintu there, okay, is negligible because it is too far from me, okay, to be absorbing the heat release from me. Okay, so that's why surrounding can be anything. It can be anything. Maksudnya kita yang specify dia. Okay, so kalau dia dah conduct dalam calorimeter, that means calorimeter will be definitely the surrounding lah, one of the surrounding. If we are using bomb, definitely kena ada calorimeter tu. If we are using coffee cup, calorimeter, information, the heat capacity of calorimeter is not given pun tak apa. Because kenapa? We assume that the coffee cup, okay, ataupun the calorimeter, dia absorb the heat tu is negligible. The heat absorbed by the calorimeter is negligible. This is for coffee cup calorimeter, the constant pressure. Okay, sebab dia punya kebolehan material dia tu, dia tak serap heat. That's why bila you pegang, you minum air panas kan, dia pakai dalam styrofoam cup tu kan, you rasa panas tak? Tak rasa panas kan? Sebab there's no heat release dekat situ. Heat tidak terleak, melainkan dia bocor lah kan. Ataupun you rasa sikit je. Ataupun you tak rasa at all. Kalau bagus, lagi bagus cup tu, lagi you tak rasa apa-apa. Okay, maksudnya the heat is contained in in the cup. Even the styrofoam, the coffee cup, the styrofoam itself does not absorb any heat from the drink. Okay, contohlah. Okay, done. Okay, so this is the summary, right? Okay, okay, so far, do you have any question related to calorimeter before we move further to the next subtopic? Ada ke, guys?
No,
Please
madam.
respond.
No, madam. Clear.
Okay, lagi.
No, madam.
Alright.
No, madam.
Lagi, bau 4, 5,
No, madam.
Clear, madam.
6, 7,
Faham, madam.
Tak ada, madam. Faham.
8, 9,
Clear, madam.
Clear.
Clear, madam.
10, 11,
Mengerti, madam.
cukup ke 15.
Ulang-ulang boleh, madam?
12.
Boleh, madam. Ulang-ulang boleh.
Boleh, madam.
Tak boleh orang lain. Lagi 2 lagi.
Boleh, madam.
Madam.
14.
Boleh, madam.
Okey. Bagilah saya semangat sikit. Okey. Rasa macam cakap seorang-seorang tu dah memang rasa macam tu. Tapi bila ada respon tu, bila 1-2 respon tu pun tak sedap juga. Naklah banyak sikit responnya. Okey. Alright. Okay, moving on. Heat exchange between two material at different temperatures. Okay. Alah, ni awak tahulah. Okay. When two objects at, saya pun dah mention about this in our earlier slide. Saya dah cakap dah pasal ni. Okay. When two objects at different temperature are placed in contact, heat will flow. Okay, heat will flow from the material with higher temperature to the material with lower temperature. Okay. So, sampai bila the heat will flow? Okay, the heat will flow until both material reach the same final temperature. Okay, the amount of heat energy lost by the hot material equals to the amount of heat gained by the cold material. This is Q system is equal to Q surrounding. If the system release the heat, okay, that means the surrounding will be absorb the heat. Okay, dia cerita yang sama because that is the principle of heat exchange. Okay, Q hot ke Q cold ke, you define the system. You nak study the hot, that means that is the one that will be releasing the heat, then the cold will be surrounding lah. Okay, alright. So MCS delta T, MCS delta T, dia akan reach to a point bila dia transfer kan, the heat will transfer from the hot object to the cold object. Okay, maksudnya ada temperature difference dekat situ. So dia akan transfer dekat situ. The heat will transfer. Okay, nampak tak dekat sini? When they are in contact, normally bila dia direct contact, dia punya heat transfer tu lebih laju lah. Okay, so faster rate of energy transfer from hot to cold. Maksudnya faster, dia lebih laju. The heat will transfer at higher rate compared to kalau yang daripada cold ke hot. Okay, sebab at the end of the day dia akan balance. Balance, kita tahu dia balance. Macam mana, how do we know that it's already equilibrium? Bila kita check the temperature, there's no change in temperature. So that indicates that the heat transfer is now at equilibrium. Okay? So tu konsep dia sama. So we got be using the same concept, the same relationship. Ini punya slide patutnya di awal-awal Okay, dia keluar dekat sini pula. Okay, tak apa. Dia benda yang sama. Okay, benda yang sama. Okay, in this case, cuba tengok. Example. So we have aluminium, cube of aluminium. So this is the temperature, initial temperature of the aluminium. And then it is being submerged, direndam into this mass of water. Okay, this mass of water, which the temperature is 15.4. So nampak tak ada difference in temperature. So you identify lah, oh yang ni lebih panas than this one because the temperature is higher kan. So bila the temperature is higher, so the heat will be released from the aluminium to the water. So aluminium will have an exothermic reaction, whereas water will have an endothermic reaction. Okay, calculate the final temperature at thermal equilibrium, final temperature of both substances. Okay, alright, so you need to have this first. You boleh pakai ni and then you define lah. In this case, the hot will be aluminium. Be specific, okay guys? Be specific. Alright, so the hot will be aluminium, the cold will be water. And then MCS delta T. Okay, please be careful on the delta T. Okay, calculate for the delta T. And then last kali baru you tolak. Okay, baru kembang kan. Baru kembang maintain dulu sebab bila you kembang nanti takut you apa nama tu pening. Be careful bila banyak sangat nombor ni kita takut kita miss out. Okay, sebab saya macam tu. Saya agak careless. Jadi kita jangan kembangkan dulu. Jangan buat temperature TF and then tu. Bila you kembangkan nanti kita takut bila kita nak carry forward tu, nak tulis balik tu, kita miss out. Okay, so let's reduce that the chances to make mistake. Okay, so kita dah dapat yang ini. Okay, ini pun dikembang juga ke tak? Tak, dia tak kembang lagi. Okay, barulah bila dah ada, okay, ni dah jadi sikit, baru you kembang. Okay, that is just my suggestion. Kalau you rasa you suka nak buat macam ni, tak kisah, go ahead. Okay, just be careful. Alright. Okay, checkpoint 13. Okay guys, I give you like 2 to 3 minutes for you to complete this checkpoint 13. Okay, alright. Okay, do it now. Right. So okay, so let's go through the question. A hot piece of copper metal weighing 350 gram is heated, okay, to 100 degrees Celsius. It is then placed into a coffee cup calorimeter containing 160 gram of water at 22.4 degrees Celsius. Then the water warms and the copper cools until the final temperature is 35.2 degrees Celsius. Okay, right. Calculate the specific heat of copper given that the specific heat capacity of water is this. Okay, cerita dia sebenarnya dia nak ceritakan that the copper metal, the heated copper metal, okay, is being placed in water. Okay, is being placed in water. So itu ceritanya. So that part is exothermic. Because the hot copper metal, okay, will be releasing the heat to the water. So that I'm talking about the copper metal. Okay, so the copper metal is will be having the exothermic reaction, exothermic process. Whereas water will be an endothermic process. Tapi kalau we are talking about this statement dekat atas ni, tapi sajalah, this is just to highlight you guys, okay, to highlight to you guys that you sepatutnya bila you go through the question, you boleh identify, oh, this is an endothermic process, this is an exothermic process. Okay, alright, so this part right here is an endothermic process, okay, for the copper metal. Okay, a hot piece of copper metal is heated to 100 degrees Celsius. So copper in this case, okay, is apa nama tu, dia undergoes an endothermic process. Sebab apa? Dia absorb the heat. Kita panaskan kan? Bila kita panaskan something, yang kita panaskan tu, okay, in this case the copper metal will be absorbing the heat. So bila dia absorb the heat, the copper metal is having an endothermic process. Okay, untuk first step ni, this is saja extra kan. Lepas tu dia kata, ni cerita kedua, ni case kedua. It is then placed, yang panas tu, dah panas tu, then placed into a coffee cup calorimeter containing water at this temperature. So second process ni adalah exothermic because the copper is now release the heat because it is hotter than the water. Okay, it will be releasing the heat to the water. Okay, so dia sekarang jadi exothermic and the water will absorb. So water is now endothermic reaction. Okay, alright. So bila you dah tahu benda tu, kalau you nak kena calculate ke Q ke apa later on, you dah ada dah dalam otak tu, maksudnya you should get negative value because this is an exothermic reaction. And same goes to the temperature. Kalau you nak kena calculate the final temperature, you kena dapat the value should be higher. Betul tak? Sebab dia release the heat kan? So benda-benda macam tu, itu adalah tips-tips yang helps us in identifying whether the final answer yang kita dapat tu betul ke tak. Dia bukan simply you tekan calculator je macam tu sayanglah kalau macam tu. You kena, dia ni logik tak jawapan dia ni. Okay, alright. So you need to have this first and then you dah ada this one. The rest are all mathematical. Okay, so you again do not forget the unit. Okay, CS. So CS you should have JG -1 negative degree Celsius -1. Alright. Okay, so maksudnya dia tak ada cancel lah. Ada cancel dekat sisi. Is it? Yep. Selesaikan dulu lah. Okay, so you cancel this one. Sebenarnya gram pun also cancel out and you are left with this one only. Okay, alright. Okay, done. Okay, jom next subtopic. Okay, any questions so far guys? Ada? Okay ke?
Okay,
madam.
Okay, madam.
Right, okay, good. Thank you. Okay, now let's move on to the next subtopic, determining enthalpy of reaction delta H.
Madam.
So this one we have one learning objective. Make sure that here. Okay ke? Okay. Alright, mungkin lagging kot. Okay. Make sure that you are able to determine the enthalpy of reaction using direct method. What is direct method? Okay, so that will be explained later. Okay, right. Okay, the earlier part yang awal-awal tadi, okay, kenapa kan tiba-tiba tadi bukan dah kira enthalpy of reaction ke? Tiba-tiba kenapa subtopic ni determine the enthalpy of reaction which is delta H? Apa yang kita buat all this while before this, betul tak? Okay, you notice tak? Sebelum ni, the enthalpy H has been given to us. The value has been given to us. It's just that kita play around je. Okay, the coefficient kita, instead of 1 dari 2, then kita akan adjust the delta H. Okay, and then same goes to this one. Okay, this is maksudnya kalau kita conduct experiment, simple experiment. Okay, we can calculate the Q and whatnot. This one. Okay, in the calorimeter. This is what we call simple experiment lah, where we can conduct in the lab. Kita boleh conduct setakat neutralization, boleh, tak ada masalah. Okay, we can use calorimeter to measure the heat release ataupun heat absorb. Ataupun earlier lagi in the slides ni, kita ada this part yang kita kena kira, this one, enthalpy change of reaction, betul tak? Okay, you perasan tak? All the enthalpy values are given. Okay, dia dah bagi kepada you, you just nak tahu stoichiometry, and then when you change this to 2, okay, you times everything with 2, you need to multiply the value with 2 as well, okay, and so on. But the value of delta H is already given. Kembali kepada subtopik kita yang kita nak masuk ni, which is determining the enthalpy change. This one. Okay, determining enthalpy of reaction. So, in this subtopic, we are going to determine the enthalpy of reaction. Okay, yang awal-awal tu dia dah bagi dah. Yang ni kita akan determine from scratch lah, from the beginning. Kita kena determine what will be the delta H. Okay, so there are two methods. There are two methods to determine the enthalpy H of reaction. Okay, so normally untuk reaction macam ni dia tak simple. Okay, it is a little bit complex. Okay, and it requires certain apparatus, certain glassware ataupun specific glassware, okay, in order to be conducted. So susah lah nak buat kat lab. Okay, dia tak semudah pakai coffee cup calorimeter tu, tak. Sebab you kena make sure that it is really insulated and whatnot. Okay, so dia ada cara lah nak buat tu. So that is our limitation. Okay, so how do we solve? How do we determine the delta H of reaction if we cannot perform this reaction in the lab? So what are our options? Ada cara dia. So kita boleh pakai direct method, and we have another method that is known indirect method. Okay, for direct method, we are going to be using this one. Delta H naught reaction, okay, is equal to the sum of the delta H of formation. This is very important, guys. Okay, this is only applicable for formation sahaja. I mean, if the delta H is given in terms of delta H formation. Okay, the sum for the product, okay, in formation, delta H formation minus the sum of the product, the sum of the reactant, okay, for the enthalpy of formation. Okay, alright, so this is the direct method. On the other hand, for the indirect method, we are going to be using this Hess's law. Okay, Hess's law ni is equal to, this is the formula of Hess's law lah in general. Okay, so even for the Hess's law itself, we have two methods. We have algebraic method and energy cycle method. Both of them, okay, is you should know both of them. You tak boleh pilih salah satu. Unless soalan suruh pilih, tak apalah. Okay, but in case you suka energy cycle method, but the question is asking for algebraic method, you bagi energy cycle method, you are not answering the question. Okay, so you need to know both of them. Okay, so we will discuss each one of them. So now let's look at the direct method first. Okay, direct method. Maksudnya dia direct lah, dia straightforward. Okay, alright. So the standard enthalpy of reaction is the enthalpy change that occurs in the system when the substance is transformed by a chemical reaction under standard condition. Okay, maksudnya it's basically a reaction that is conducted under standard condition because we have this, right? Okay, so the reaction is a general term used to describe a reaction lah, a chemical reaction. So reaction can be combustion, can be neutralization, it can also be formation, kan? So that's why saya kata reaction can be general. So it's up to us, okay, we can identify the type of reaction itself. Okay, so dia bagi kat sini reaction lah, general dia kat situ. So the enthalpy change that occur in the system when a substance is transformed. Dia pakai the word transform. Okay, by a chemical reaction under standard condition. Dia tak cakap transform can be in a form of decomposition, it can also be form in combustion ataupun formation kan, transform. Transform is general term. Bila dia go for combustion, maksudnya dia dah specific. Formation, neutralization, those are cara macam mana it can be transformed. Okay, so that's why enthalpy of reaction ni is rather general. Okay, alright. The standard enthalpy of reaction is related to the standard enthalpy of formation. So dia related to the standard enthalpy of formation of reactant and product by the following equation. Okay, consider this equation. Okay, example. Okay, alright. So we have A, B producing C and D and their coefficient. Okay, so how do we calculate? Katakanlah soalan tanya, calculate the enthalpy of reaction for this reaction. Okay, alright. So if you are using direct method, that means we are using the formula lah. Okay, alright. Dia kata product minus the reactant. Okay, alright. So you have to have, this is the product kan. Okay, you have to have the enthalpy of formation for A, the enthalpy of formation for B, the enthalpy of formation for C and D. This is for reactant. Okay, so you kena ada this information for the enthalpy of formation for each one of them. Baru you boleh pakai this direct method. You cannot use this direct method if you don't have the information on the enthalpy of formation for reactant and product. Okay, so N mana N? This one N. N is the coefficient of the reaction lah. So this one we can obtain from the balance equation. Okay, so C, this is for C. D, a small letter D, this is the coefficient for D. Okay, we can refer from the balance equation there. Okay, alright, so let's look at an example here. Use direct method to calculate the enthalpy change for the following reaction. So soalan nak tanya, what is the enthalpy change of this reaction? Berapa? Kita nak kena kira, nak letak kat tepi ni nanti kan? Okay, so this is the information guys. Okay, right. So like I said, if you are using direct method, okay, the question has already specified. Use direct method. That means bear in mind, if you are using direct method, that means you need to have the enthalpy of formation for each one of the reactant and product. Formation, enthalpy of formation. Okay, let's check whether we have each one of them. Kita ada 4, that means we should have 4 lah. 4 enthalpy of formation. Okay, so let's check. C2H2. Do we have C2H2? Okay, check this one. Okay, this is the formation of C2H2. Yes, okay, all of them. All the reactants are in element state. Okay, this is 1 mole of product form. Katakanlah dia saja je manipulate this kepada 4, this one jadi 2, this one jadi 2. Can we manipulate this in order to form formation reaction? Yes, we can. We can just simply bahagi je dengan 2. Contoh soalan. Contoh saya bagi. Katakanlah ini tiba-tiba kan you dapat 2. Yang the rest dah okey dah. Semua dalam bentuk elemen. Tapi you dapat sini 2 mole of C2H2. Okay, so this reaction does not represent the formation, but we can edit, we can alter this reaction so that we can get the formation reaction. Okay, kita just nak dapatkan dia 1 mol kan, sebab the rest are all already in constituent. So, kita divide lah with the coefficient yang ada pada substance tu. Okay?
Madam,
Ya.
dia mesti semua 1 mol produk akhir tu.
Sorry?
Dia mesti yang produk tu kena 1 mol
Ya, formation kan? Ingat tak
okay.
formation last time? Ini saja je saya bagi contoh, tiba-tiba kan kepala saya ni kadang-kadang dia teringat soalan pernah keluar. Saja je soalan tu. Dia sengaja instead of dia bagi 1 mol, dia nak menyusahkan hidup kita, dia bagi 4 carbon, 2 hydrogen and then 2 C2H2. Saja je dia bagi macam tu. Okay? Kita tahu kita nak formation, tapi bila kita check, this is not 1 mol. Alamak, macam mana tak tahulah. Okay? Alright. Jangan panik. You sebenarnya boleh modify this one so that you can get the formation. Macam mana? You just need to divide by 2 sebab you nak jadikan this one into 1 mol, betul tak? So, bagilah 2. Dah dapatlah formation. So, jangan panik. Okay? Alright. So, that's why saya kata tak semua benda yang soalan akan bagi direct. Okay? You sendiri kena tahu. That's why by definition, you should know. Okay? Alright. So, okay. So, this is for C2H2. This is the formation. Okay, again, don't expect the question give out F ni. Jangan, tolonglah. Okay, jangan. Kalau tak bagi, macam mana kita nak tahu dia formation? Check lah this equation. Ya, ataupun soalan bagi kat atas ke, ataupun dia tak bagi tapi you have the equation kan, you can check. Kalau dia bagi without the F, imagine. The F is not given. Sebab ada student dia rely pada F ni. F ni, yuk dia tak dapat apa, tak ada apa pun saja nak to specify lah. But without the F, okay, dia still adalah enthalpy. Kita boleh define dia adalah enthalpy apa from the equation. Okay, alright. So we have the C2H2, we have CO2, right? Okay, CO2, we have H2O. Okay, ni senang cerita dia dah bagilah dalam formation. Saya saja je bagi awak contoh-contoh soalan yang dia possible nak tanya dalam exam. Okay, contoh-contoh kesalahan student buat. Alright, so ni dah bagi formation, should be ni lebih easy lah. Okay, moving on, what else? Okay, tapi oxygen, how about oxygen? Oxygen is not given kan? Okay, remember last time saya cakap, normally untuk gases, okay, untuk gases, dia exist dalam bentuk gas kan, dia exist dalam bentuk duit atomik kan, dalam duit atom kan. They have the enthalpy of formation for normal gases ni will be 0. Okay, will be 0. Oxygen, nitrogen, what else? Oxygen, nitrogen, lagi apa? Hydrogen. Okay, so those are the enthalpy of formation will be 0. So kalau janganlah ni tak cukup 4, tak ada lah. Maksudnya kalau dia tak cukup, bukan saya tak boleh pukul, saya tak boleh cakap macam tu. Okay, you kena tahu that normal gases, okay, dia adalah 0. Pergi patah balik dekat table, ingat table formation tu last time. Cuba tengok dekat situ. Kalau tak ada, sebab banyak kan substance kan, so not all will be included in the table. Patutnya ada lah, you akan nampak dia 0 kat situ. Okay, so 0. So this will be 0. Okay, so we have all the delta HF. Bolehlah masuk dalam formula. And don't forget the coefficient guys. Don't forget the coefficient here. Alright. So we have them already. Okay, so how can we solve this problem? We are going to be using this direct method. So this is the formula. Okay. Alright. Salah. Nak kena ambil this one. Nak transfer. So that's senang nak refer kan. Take this one to this one. Senang nak refer, letak depan mata. Okay. Okay, alright. So this is the product dulu, okay, minus the reactant. Okay, product. So 4 CO2, 4 don't forget. Okay. Okay, this times this one. Okay, boleh je terus kepada this one. 4 mole, okay, times negative 393. Do not forget the negative sign. Okay, negative yang selalu lupa. Tambah tu not problem kan. Okay, so this is for CO2, right? Times H2O. Okay, this is 2 mole of H2O. This is for H2O, okay? Right, so this mole will be cancelled out, okay? Mole can be cancelled out. Okay, this is for product. Okay, how about reactant? Okay, so we have 2 mole of, this is for C2H2, right? Okay, again, this can be cancelled out. Okay, all right. So how about oxygen? So 5 mole of oxygen times 0 because the enthalpy of formation for oxygen is 0. Dan matematik lah, tekan je lah calculator. Dapat lah. That's why you dapat kj. Tak ada kj per mole lah. Okay. Yelah with respect to this one. Tapi kalau you with respect to the coefficient, kalau you nak tengok balik coefficient tu, sebenarnya you boleh. This mass, this amount of ni is for 2C2, 2 mole of, like I said last time, okay, this also represent 2 mole of C2H2. This also represent 5 mole of oxygen. This also represent 4 mole of CO2 and H2O. Okay, alright. So you may have this as your, yelah, bolehlah letak. Inilah yang kita nak letak kat sini. Berapa? Okay, alright. Okay, so guys, please try this checkpoint. Checkpoint 14. Cuba buat dulu. Okay, alright, settle ke?
Settle.
Ya, madam.
Alright. Okay. Okay, alright, so let's go through the question. Nitric acid is used to make many products, including fertilizers, dyes, and explosives. The first step in the industrial production process is the oxidation of ammonia, as in the equation below. The first step in the industrial production process is the oxidation of ammonia, as in the equation below. Okay, all right. So this one later on will be used to produce nitric acid. Okay, all right. Okay, see soalan tak tanya pun pakai direct method ke, pakai indirect method ke. Later cuba you imagine in exam, okay. Soalan tak specify. Okay, so you may use direct method, you may use indirect method. It depends on the suitability, kesesuaian dia. Okay, that's why you should know if you want to use direct method, you kena ada apa. Okay, sebab soalan dia tak specify. Macam soalan this one just now, right? This one dia specify, terang-terang use direct method. Kalau you dapat soalan macam ni, kira rezeki you lah. Okay, dia normally dalam soalan dia tak specify. You boleh decide you nak go for direct method ataupun Hess'S law. Kadang-kadang soalan nak Hess'S law lah. Hess'S law is the indirect method just now. Okay, yang ada flow chart just now. Okay, alright. So macam ni. Dia cakap ke? Tak cakap. Tapi when we look at the information given, they are given in terms of delta H of formation. Okay, so terus dia klik, ni boleh ni pakai direct method. Okay, let's check whether we have all of the delta HF given for each of the reactant and product. Okay, so we have 1, 2, 3, 4. So we have 4. Dia dah ada label, dia dah cakap kan dekat situ, dah obvious. And for this one, nampak tak dia tak bagi what do we call that? Equations. Okay, cara dia soalan tu diberikan. So dia instead dia mention dekat atas enthalpy of formation. But can the question ask you to write the chemical equation of any of the reaction here, any of the substance here? Boleh. Okay, sebab you dah tahu sini information, by right you should know how to write the chemical equation for formation reaction. Nampak tak? Benda-benda macam tu you kena aware of lah. Okay, alright. So 1, 2, 3, 4. So we have 1, 2, 3, 4. Okay, just nice. Okay, kita boleh pakai lah. Okay, alright. So don't forget the ini pun dia tertinggal ke apa ni? Oh, dia kurungkan dekat sini terus, and then we have the kj per mole there. Okay, alright. So we can simply cancel out lah later. So mole ni sebenarnya nanti dia total kan, dia akan cancel out. Okay, alright. So this is your answer. Please be careful, okay guys. But this one looks intimidating. At least for me lah. Okay, sebab macam banyaknya lah nak kena consider, and then this one pun is considered a lot. Number tu banyak nak kena letak in line macam tu. Sebab you need to write down this one because this will be your working. You cannot just simply tekan calculator dapat final answer. Hilang markah kat situ. You kena tulis. Bila tulis, of course we will check each one of them. If there is a missing number ataupun unit ke apa, okay, of course markah akan ditolak ya. Be careful. Okay, alright. So done with direct method. Okay. Saya kan suka buat macam ni. Ni. Saya nak. Okay, alright. So moving on to indirect method. This one. Settle, okay. Alright, indirect method. Hess's law. Students should be able to state the Hess's law and use it to determine the enthalpy change that cannot be determined directly. Okay, alright. So, like I said last time, okay, not every reaction can be performed in the lab. It's not as simple as that. Okay, in order to perform a reaction, a certain condition must be required lah. Okay, kita perlukan certain condition. So it's not easy lah. it's not easy to have that condition. Control condition. Tambah pula kalau kena main dengan pressure. Pressure, temperature higher than 200. Okay, so that would be inilah. Itu yang berlaku dekat industri lah. Kilang-kilang macam tu. Dia punya condition tu dia kena set. Okay, so dia main dengan pressure normally because dia nak fast. Okay, bila you nak fast, you kena main high temperature and kena main high pressure. Okay, we don't have that in our lab, especially in Asasi punya lab lah. Okay, right. Okay, calculating enthalpy of reaction. Okay, it is impossible to measure delta H for every reaction because some reaction cannot be performed in the laboratory. Okay, since enthalpy, which is H, is a state function, the delta H obtained from an initial state to its final state is independent of the reaction pathway. So you should know what does it mean by a state function. State function means it depends on the final outcome. Okay, dia tak depend on the process nak dapatkan the final tu. So itulah namanya state function. Okay, dia depends on the initial state to its final state is independent of the reaction pathway. Right? Okay, contohlah. Okay, katakanlah you dekat college kan. Okay, saya ada 2 student. Okay, I ask these 2 students to come and meet me at 2 o'clock, for example. Okay, at 2 p.m. Okay, so 2 orang ni, cara dia nak datang jumpa saya dekat lab. Okay, dekat lab. Dekat bangunan etika tingkat 5. Okay, so cara nak sampai dekat lab tu ada 2 cara. Satu, naik tangga, you may use the stairs and also using the lift. Okay, so nak pergi jumpa saya dekat lab. Okay, so this is you dekat college. Okay, saya Madam Fariza, level 5, bangunan etika. Okay, nak jumpa saya. Okay, so ada 2 cara nak sampai ke saya tu kan. Satu, daripada college tu, you pergi straight ke bangunan etika and then you tekan lift sampai dekat Madam Fariza. Betul tak? Okay, ini yang cara straight lah. Ataupun lalu highway yang paling cepat. Satu lagi student tu mungkin dia pergi singgah Anjung. Okay, beli cekedis, beli nasi ke apa, and then jumpa pula member. Okay, member pula kawan lama borak kejap. Ada banyak stop dia dekat situ. Lepas tu pergi dekat lift pula rosak. Okay, kena pula naik tangga. And then finally jumpa Madam Fariza. Okay, nampak tak? Dia punya final state dia tu sama. Dia jumpa saya dekat level 5 bangunan etika. Tapi kepayahan dia tu berbeza. This is what we call pathway. Okay, ni pathway. Dia ada banyak pathway. Ada 1, 2 and macam-macam lagi lah pathway. Tapi at the end of the day, dia akan mempunyai outcome yang sama. So this is what we call state function. Dia tak rely on the pathway, dia rely on the before and after. Okay, the initial and the final state. So this is what we call state function. Okay, alright. So imagine lah maksudnya kalau reaction, we have a reaction. Okay, alright. So kita ada cara. Satu, kita boleh produce it directly ataupun we can use several steps ataupun we can have small reaction, okay, which can be combined to form our interest reaction, our targeted reaction, our focus. Okay, so dua-dua pun you still akan dapat result yang sama. You akan dapat produk yang sama. Okay, alright. So this means delta H will be the same even if the reaction takes place in one step or in a series of steps, as long as the reaction started from reactants and ended with the formation of products. Okay, doesn't matter apa yang berlaku dekat tengah tu, dia straight ke, dia lalu bengkang-bengkok ke, yang penting dia punya final state tu should be the same. Okay, alright. So delta H can be estimated using published values and properties of standard enthalpies. So we are going to be relying on the published values lah dekat situ. Especially kalau kita guna series of steps kan. Yang straightforward tu yang kita selalu tak boleh nak perform dekat dalam lab. Okay, contohnya you nak reactkan, you nak produce magnesium oxide, betul tak? Magnesium plus oksigen jadi magnesium oxide. Macam senang aja kan? Tapi sebenarnya dia susah sebab you have to flow through the pure oxygen. Okay, and then kalau you nak bakar open air kita ni oksigen baru 21%, yang banyak nitrogen. Betul tak? So it's not as simple as that. So you may use several other steps in order to produce your final product. Okay, and then sometimes step-step yang small step, a series of steps ni, dia orang ada buat, maksudnya publish value. Kita boleh buat sendiri and also others has performed this one, and we may use this information to help us determine the final enthalpy. Katakanlah, ni ada last time ada researchers, ada scientists pernah buat dekat step this one. Okay, so we may use that published values. Ataupun kita sendiri boleh buat. Okay, right. So therefore, to obtain delta H, calorimetric measurement for all reactions are not required. So tak semestinya you kena lalu straight. Pathway ni you kena wajib lalu straight ni. Tak semestinya. You boleh lalu jalan jauh. Boleh juga. You still have the same product. Okay. So that's why dekat calorimetric measurement. Maksudnya we ourselves measure the enthalpy directly. Tak perlu macam tu. Tak perlu sekepayahan, melalui kepayahan sebegitu. Kita ada option to that. Okay. Right. So this method of estimation is known as Hess'S law. Okay. Kita menggunakan ni. Nak highlightkan this one. Cara number 2, alternative number 2. Okay, right, moving on. Calculating enthalpy of reaction, delta H reaction, okay. Hess'S law states that enthalpy change for an overall equation equals to the sum of the enthalpy change of individual step. Okay, when you combine, like I said just now, when you combine A, B, C, you still akan dapat the overall. Okay, alright, so this is the Hess'S law. So Hess'S law stated that the enthalpy of the overall, so this will be the overall, will be the same as berapa step tadi yang kita ada. 1, 2, 3 and so on. Okay, alright, as seen in the diagram below, there are two methods of calculation under Hess'S law. So kita ada dua cara, algebraic and energy cycle method. So we are going to discuss on the algebraic method first, okay, and then we have the energy cycle. Okay, look at the example that we have here. Okay, the oxidation of carbon solid graphite to form gaseous carbon monoxide is shown in the following equation. Okay, kita nak determine this one. Okay, target kita nak determine ni berapa ni. Cara dia macam mana? Okay, kita nak produce CO. Okay, cara paling senang adalah perform this reaction directly. Okay, kita boleh perform this reaction. Tapi tak semudah itu. Okay, you nak flowkan this oxygen directly to this carbon, and you have to make sure that the carbon is completely combusted. Okay, jangan dia tak nak incomplete combustion. So there's a lot of things that you need to consider. Okay, so this can be quite tedious lah. Okay, kalau nak to have this highway, of course dia dapat je produk kita terus, tapi nak prepare this one is not an easy task. Tak dia tedious lah. Okay, alright. So alternatively, we may use the following data here to calculate the enthalpy change of reaction for the oxidation of carbon to form gaseous carbon monoxide. Okay, alright. So dia bagi dua reaction dekat situ. We can manipulate these two reactions so that we can get our targeted reaction here. Okay, again, saya repeat, we can manipulate the equation given here so that we can obtain this final equation. This is our target equation. Okay, all right. So now the strategy is to manipulate these two reactions. Okay, how do we manipulate these two reactions? Okay, let me just give you an overview lah before we go through the slides. The slide tu they go through satu-satu lah, tapi saya bagi lagi. This is like an introduction supaya lagi next you dengar lagi sekali. Okay, alright. So the plan is to get this final equation, right? Okay, kita nak manipulate kan? Okay, cara dia adalah saya clear dulu. Pakai colour lain lah, biru. Okay, alright. So how do we manipulate this equation so that we can get this targeted equation, this target equation? Okay, alright. So kita check. Okay, we have to make sure that CO must be on the product side. Okay, that because this is our target. Okay, CO must be on the product side. Okay, now let's check the equation given to us. The CO, we do have CO, mestilah ada. Dia mesti related. Dia mesti all these components in this reaction equation kena ada lah dalam equation 1 and equation 2. Barulah dia related. Okay, dia ada. Cuma dia bersepah-sepah lah. Dia dekat sini, dia dekat situ. Okay, dia terbalik. Okay, alright. So, CO should be on the product side, but we have CO on the reactant side. Okay, alright. Remember, we can manipulate. So, we want the CO to be on the product side. So, how can we do that? We can just simply reverse the reaction. Betul tak? We can simply reverse the reaction. So that kita dapat CO on the product side. And turns out, CO dia kebetulan 1, 1. Betul tak? So that means we don't have to multiply with a factor. Ingat target kita this one. Kita nak 1 mole of CO. So kebetulan this is already 1 mole of CO. It's just that it is on the reactant side. Kita nak dia product side. Okay, maknanya bear in mind that we have to reverse the equation. When you reverse the equation, you kena make this one, you kena change you have to reverse the enthalpy change lah. Okay, you have to change the sign to positive value. Okay, so that is the first step. Secondly, okay, just to be nak check lah, okay, alright, what else? Okay, carbon need to be on the reactant side. Okay, alright, so let's just check. Okay, yes, equation 2, we have carbon on the reactant side. Okay, do we need to change it? No. Kalau you tukar, that means you akan ada, you conflict lah dekat situ. Okay, and then turn out dekat dalam equation 1 and equation 2, only equation 2 yang ada carbon. Equation 1, we don't have carbon in it. Okay, alright, how about oxygen? Okay, oxygen ni dia ada 2 tempat ni. Okay, so we have to check for the oxygen. Okay, we do have oxygen. We have oxygen on the, just now dia dah terbalik kan, dia reverse kan, remember? Okay, that means kita ada the oxygen we have on the product side, and this one, equation 2, kita remain as is. So we have oxygen on the reactant side. Okay, alright, so everything is in in the correct order. Maksudnya dia betul-betul dah ikut susunan yang macam yang kita nak dekat sini. Alright, so next adalah kita tulis balik lah bagi proper. Okay, ni you reversekan, buat balik. Reversekan, you macam mana? Reversekan CO2 gas, okay. CO, you tulis balik bagi proper. Okay, half oxygen gas. Okay, don't forget this one, you have to change the sign. 283 kg per mole. Okay, alright. So this one you remain. Ni saya malah nak tulis, saya pakai balik in this one. Okay, now next apa you perlu buat? Okay, alright. So remember target nak produce this one. Okay, how can we produce this targeted product? Okay, kita kena cancel yang mana need to be cancel, and yang tak cancel tu yang akan ada dekat final equation. Okay, alright, so that's the plan lah. That is the plan. So the final equation here should be the same as this one. Okay, Alright, jom tengok dia punya working. Okay, so this is our target equation, guys. Okay, step 1. And then kita kena adjust, kita kena manipulate. So like I said just now, kita reversekan. So the sign will be changed to positive. Okay, and then kita put everything into this. Okay, so that kita nampak semua yang dah di-manipulate just now. Okay, alright. Okay, so dia macam ni if it's present on the reactant and also product, it should be cancel out. Alah, macam main unit lah, cancel out kan. Okay. Dia mesti ada dekat reactant dengan produk. Barulah dia cancel out. And then they should have the same mole lah. Okay, kalau sini ada 2, sini ada 1, so that means there will be a balance remaining for CO2 on the reactant side. Alah, tolak kan? Dia tolak kan? Maksudnya you ada 1 mole dekat reactant side, you have 1 mole on the product side. So it will be cancelled out. If you have 2 mole on the reactant side and 1 mole on the product side, dia tak fully dia ada baki dia kat situ. Baki dekat mana? Baki on the reactant side. Okay? Alright. Contoh lagi sekali, itu contoh sahaja. Okay, so we have CO2 on the reactant side, we have CO2 on the product side. Cancel. And then how about CO? We have CO? Tak ada. Tak ada CO dekat dalam reactant, dalam equation tak ada. So we only have 1 CO saja dekat sini. Okay, how about oxygen? Okay, we have half oxygen on the product side and we have 1 oxygen on the reactant side. So dia tak sama kan, coefficient kan. So there will be remaining kat situ. There will be remaining of oxygen on the reactant side. Sebab reactant side ada 1. Okay, that's why we have oxygen there. How about carbon? Do we have carbon yang nak kena cancel kan this one? No. Okay, alright. So the rest are all cancel out. Okay, so kita akan ada baki for oxygen. So kita tulislah balik. So we have carbon on the reactant side. And then kita ada this one kan. So carbon monoxide will be the product. Okay, tak apa. Kita go for reactant dulu. Okay, we have carbon. And remember oxygen just now? We have red. Kita ada baki kan. So carbon and oxygen. Half oxygen. Okay, don't forget the state guys. Equal to, okay, the product, we only have carbon monoxide. And then check, ada tak lain? Kadang-kadang mata berpindah tak nampak. Okay, we only have 1 mole of carbon monoxide. Okay, yang kita nak tahu this one. Nampak tak? Sama tak dengan overall equation kita tadi? Sama. Okay, sama. Kita still juga dapat dia. Dekat sini yang important. Okay, you have to, don't forget ini dah tukar kan, ini remain as is. You kena totalkan. You have to total up. Okay, totalkan, tambah. Ini operasi tambah dekat sini. So this is the answer. Okay?
So madam,
Yeah.
I have a question.
Yes.
Carbon dioxide tu dia tak involve kan dalam net equation kan?
Sorry?
Carbon dioxide dia tak involve dalam net equation.
Carbon monoxide is not
Yeah,
involved in the equation. You mean
Carbon dioxide.
carbon dioxide?
Ha.
It's not involved in the final equation, is it?
Ha.
Yeah, dia tak involve lah.
Maksudnya
Sebab
dia tu
we don't have
enzim lah.
carbon dioxide in the equation, betul tak?
Ha.
But we may use this carbon dioxide, okay, we may use this reaction that has carbon dioxide in it so that we can get the target equation.
Maksudnya dia tu reactant ke ataupun apa enzim namanya?
Tak. Dia adalah reactant lah. Cuma untuk reaction pertama dia adalah reactant. Reaction kedua dia adalah produk.
Oh.
Enzim tu catalyst. Catalyst tu dia cerita lain. Dia ada dekat mula-mula and then dia ada dekat final kan. Dia akan display dekat final kan. It should not be cancel sebenarnya dekat situ. Okay? Walaupun sebenarnya di cancel tapi you kena tahu itu adalah perangai enzim. Dia bukan reactant, dia bukan produk. Dia adalah catalyst. Okay? That one untuk catalyst kita akan ada dalam semester 2 topik 1 if I am not mistaken. Okay, but this one kita tak ada catalyst lah. Okay? Just to give you the peace of mind that we don't have catalyst in this topic. Okay, right. Okay. Right, so settle for that one. Okay, this is what we call algebraic. Alah, macam mathematics sikit kan, macam transfer sini, transfer tu. That's why it is called algebraic. Okay, alright. So the other one is energy cycle method. Sebenarnya boleh nampak dah dia punya flow dia tu. Okay, energy cycle. That means you have cycle lah. Okay, they are interconnected with one another. Okay, cuba tengok ni kan. Alamak dah serabut. Okay. Apa yang ada dekat sini dalam equation 1 and equation 2, their component, okay, we do have it in the overall equation. Maksudnya dia tu interconnected. That means we can manipulate so that we have an energy cycle. Okay? Dia kena mengena lah kan. Apa yang ada dekat sini ada dalam this our targeted equation. Okay, dia tak boleh lah tiba-tiba nitrogen tambah oksigen jadi NO. Kan tak ada kena mengena dengan reaction ni kan. So tu tolak tepi lah. Dia mesti ada kena mengena. Right? Therefore, we can have our energy cycle. Okay, we can construct ataupun we can manipulate so that it is all connected. So how do we do that? Okay. Banyak ni cakap ni. Okay, an energy cycle is a diagram that shows interconnection of 3 or more reaction. Okay, it is constructed to find unknown enthalpy change. Again, what we want is to find this delta H reaction. Okay, through a different route, H2 and H3 that form the same final product. Okay, look at this. This is what we call energy cycle. Okay, we want to produce A. We want to produce A. We want to produce B from A. Okay, nak produce B from A. Okay, ini direct, ini lalu highway. Alternatively, to produce B, we can also have we produce C first, okay, and then produce B. Okay, so this is like I said state function tadi, kita boleh samakan H1 is equal to H2 plus H3. Betul tak? So that is what we call cycle. Nampak tak cycle? They are connected there. They are interconnected. Okay? So to construct an energy cycle, the following condition must be satisfied. Two of the equation have the same product. Okay, dia mesti related lah. Two of the equation have the same product. 2 out of 3 equation have a non-enthalpy change. Okay, dia mestilah ada delta H2 sebab we want to find this. Imagine if we don't have these two. How do we find this enthalpy change of reaction? Kita tak ada information yang cukup. And all arrows should be drawn towards the product. So this is the part yang kita boleh reversekan ke? Okay, kalau perlu. Okay, dia punya focus is to make sure that all arrows should be drawn toward the product. Okay, all arrows should be drawn toward the product. So in order to do so, you may need to reverse the reaction. Okay, so that dia drawn towards the product. Okay, tak payah sembang banyak, tengok contoh je. Okay, using the same example that we have just now, kita boleh pakai untuk this one, energy cycle method. Okay, alright, cuba kita manipulate dia tadi. Tadi algebraic, this one we have energy cycle. Okay, so this is our target equation, right? Again, we want to find this equation 1 and equation. Okay, how do you arrange this equation 1 and equation 2 so that you get this target equation? Okay, alright. So my tip would be, kalau saya lah, to solve this energy cycle method, I will start from the target equation first. Saya tulis the target equation, okay, and then from there, okay, kita tengok equation 1 and equation 2 dulu Alright, so we have this, okay, so equation 1, CO producing CO2. CO react with oxygen to produce CO2. Okay, alright, so CO yang kita dah ada tadi from the equation, the target equation, kita buat arrow producing CO2. Okay, alright. So for oxygen, it can be manipulated. Like I said, okay, oxygen boleh kita boleh manipulate oxygen tu. Macam daripada slide awal yang combustion lah, apalah. Okay, kita boleh manipulate. Okay, alright. So oxygen, instead of kita put in the equation, kita boleh letak on the arrow itself. Okay, alright. So CO to produce CO2. Kita follow je equation tu dulu. Follow equation dulu. Nanti baru kita tengok, oh, this one kita kena reverse kan. Okay, so we do that later. Okay, kita produce the equation 1 and equation 2 dulu. Okay, CO plus oxygen to produce CO2. Okay, alright, so this is equation 1. Okay, how about equation 2? Okay, we need the carbon. We have the carbon from the target equation just now. Okay, this carbon we react with oxygen to produce CO2, which is this one. Okay, betul tak? Alright. Okay, inilah based on the information given. This is based on the information given. Alright. So now is the time for us to manipulate. So that, ingat kita punya target tu highway dengan lalu jalan lama. Kena lalu jalan jauh. Okay, our target is to produce CO, betul tak? This is our, okay, change color guys. Okay, we want to produce the CO. Okay, how do we do that? Okay, this is okay, all right? So this is okay. So let's not alter anything for this equation 2. Okay, all right. Equation 1, how about equation 1? Because we want to produce CO kan? So we have to reverse this one. Arrow ni patutnya ke CO2 kalau based on equation 1 here. Okay, but we have to reverse it. Okay, kita kena reverse, so putarkan ke sini nanti. So that you akan dapat flow ke CO. When you putar, when you reverse, so the sign will be opposite, will be reverse as well. Okay? Ta-da! See? Sama juga, you still have to total it up. Okay, you have to total up and then you dapatlah this one. Okay? Right. Okay ke? Ada soalan? Lepas ni kita checkpoint aja. Apa kan? Okay, that's nice. Okay, alright. So you need to understand these two method. Saya boleh kata confirm keluar. Okay, 98% lah confirm keluar lah dalam exam. Okay, cuma we don't know whether it's direct method, is it Hess'S law ataupun these two. And then Hess'S law pun can be algebraic ataupun saya asyik nak cakap kita Krebs, okay, Krebs cycle, okay, energy cycle, okay, tapi confirm keluar. Okay, if there is no question from you guys, okay, could you please try this checkpoint 15 guys? Okay.
Okay, madam.
Okay. Okay, try using algebraic and also energy cycle. Yeah, try both. Alright, okay. So since we don't have all day, okay, walaupun tak siap pun kena gak lah go through. Tapi at least you try lah. Okay, try. Katakanlah, imagine kalau you kena, saya buat pop quiz ke ataupun kena masuk exam kan. Berapa persen agaknya yang you've been absorbing so far. Okay, alright, calculate the standard enthalpy of formation of acetylene C2H2 from the following data. Okay, alright, so you have been given, we have three equations given and the delta H, the change in enthalpy as well. Alright, so apa yang missing dekat sini guys? Apa yang missing dekat sini? What is not given to us? Directly. Apa yang tak diberi kepada kita directly?
Equation yang dia nak.
Targeted equation.
Okay, the target equation. So it's not given to us. So is it really the problem? Is it apa kata tu? Apa nak kata? Tak tahu nak kata apalah. Okay, alright. So dia tak bagi kita the target equation. So in order to solve this equation, this problem, you need to have that target equation. Kena ada target equation. Tak boleh skip the target equation. Okay, alright. So normally, okay, contoh yang tadi tu dia bagi kan, but the question can also it is not compulsory lah for the question to give out the equation, for the target equation. Okay, tak perlu. Apa yang dia perlu bagi adalah hint ataupun info. Calculate the standard enthalpy of formation of acetylene. Okay, alright, so this is just, you have to come out with the equation because it is mentioned here, okay, the enthalpy of formation. So you have learned that to write the chemical equation for formation of substance, okay, it need to be 1 mole of that substance and then the constituent should be in element state. That is all. So, you bolehlah buat you punya target equation sendiri. Okay? Alright, so C2H2 in, okay, tak tahu. Okay, is it gas? Is it liquid? Alright, the tips would be, you check dekat equation ni. Cari C2H2 kat mana? Oh, ada satu. Oh, gas. Letak sini. Another equation and sebab target for this type of question, of course, your target equation will be 1 mark. Dapat markah kat situ. Okay, that means it should be complete lah. Kalau tak complete without the state and what not, tak dapat markah lah. Okay, alright. Okay, and then you kena ada carbon, right? You kena ada carbon, solid, graphite, plus hydrogen. Oh, that is all. Okay, hydrogen gas H2 lah. Okay, now time to balance. Okay, so kita balance kan. So 2CH2 is already balanced. This one cannot be altered. Siap lah. Delta H of reaction. Sebenarnya kita boleh juga delta H of formation because we are dealing with formation reaction, betul tak? Tapi just letak reaction pun okay. Letaklah formation lah sebab dah mention kan enthalpy of formation. Okay, letak F kat situ. This one to be determined. Okay, so dah yang lain tu apa masalahnya lagi? Dah tahu dah target equation ni kan. Pusing sana, darab 2, darab 3, darab ke coefficient ke. Okay, so C2H2 need to be on the right hand side, but we have C2H2 on the left hand side. And then kita nak 1 mole. Here we have 2 mole. Kita tak mahu 2 mole, kita nak 1 mole. So kita kena adjust. We have to reverse and we have to divide by 2. Don't forget, if you change any of this chemical equation, you kena usik this one too. Okay, you kena, sebab jawapan tu yang ni, yang kat sini ni penting ni. Your final answer. Okay, and same goes to the rest lah. Okay, so this will be your answer. Ni dia punya steps lah. Okay, apa perubahan yang dia buat, dia tunjuk kat situ. And you reverse, dia tak, this one dia tak reverse, okay, sebab carbon dekat kiri It's just that you have to multiply with 2 dekat situ. Okay, alright, so you have to check for each one of them. And then finally you dapatkan this one. Ini proper yang cantik. Ini working lah. These are the working lah. Okay, these are the working, and then this is the part where you cancel out. Okay, you kena make sure that at the end you dapat the same as what we have for the target equation. Okay, alright. So normally untuk question macam ni 3 markah. 3 markah ya. Alright. So that is for, what do we call that? This is for, oh my God. This is for algebraic. Okay, jom tengok apa nama tu, energy cycle. Start from here. Okay, start from here, and then dia bagi 3 equation kan. So equation, this is 1, 2, and 3 equation. You kena connect them. Okay, alright. So initially dia sebenarnya menghala ke sini, betul tak? Dia menghala ke sini. So that means you have to reverse it. Boleh boleh macam ni. Carbon jadi carbon dioxide. Hydrogen jadi H2O. And then these two can be combined to produce C2H2. Betul tak? This is third equation if I'm not mistaken. Betul tak? Third equation. This one. Equationnya ni. Reverse kan. Betul tak? Betul je lah. Okay. We reverse it. So inilah dia punya. You kena make sure that when these are combined to produce the same product. So saya punya suggestion adalah prepare dulu based on equation yang dibagi. Dia menghada ke sini sepatutnya. So kita adjust, later baru kita adjust so that kita dapat the same product. Okay, alright, then you combine lah everything. So make sure you bila you times 2, you kena multiply the enthalpy change as well, right? Okay, so that is all. So we have two more checkpoints. Okay, I believe we have 2 more checkpoints. So please complete the checkpoint. Okay, I'll show you the working tomorrow, and then we will try to finish up the topic. Okay, so we have one more, which is the lattice energy. The lattice energy, the Born-Haber cycle. What is Born-Haber cycle? Is the application of Hess's law. That is all. Is the application of Hess's law. Okay, alright. So itu saja for today, guys. Thank you, everyone. Okay. Right, and Assalamualaikum. Bye-bye, guys.
Thank you, madam.